How many people do we have?
All right, we're live.
Welcome again to another one of our educational videos. We're going to be talking about science, and we're going to be doing science experiments.
Our little trick has me off the screen and has some of the table disappeared, but
Okay, we okay?
good enough.
All right. So, welcome. My name is Marty Shaw. I'm the science teacher here at the Delphian School in Sheridan, Oregon. This is my friend and associate, Sam Silver. Sam is going to be assisting us today, and if you have comments you would like to send in the Q&A box, Sam will be taking them and reading some out loud. Is that right, Sam?
That's right.
Okay. Well, the first thing I wanted to do, we're going to have some fun today. At least I think we're going to have fun today. I like to have fun. So can you all see this, this little bit of clay with this blue candle here? Well, what happens when I move it right here? Can you still see it? What? Oh, Sam, you want to, may I?
Mm-hmm.
Block? So sometimes, sometimes when you see something that looks like magic, it's really science. What we have here, it looks like we're in my science lab. That's what you're seeing. But this is really a green screen. You might have seen green screens on television. Weather forecasters have a green screen here, and then they're looking this way, and there's a picture of what they can see themselves moving their arm and that sort of thing. So there's a green piece of paper here. When I lift the paper up, you can see what's below it. So this seems like magic to have a blue block disappear, but it's really science.
Good. Here, I can take off the green screen effect and they can see what's actually.
Okay, have them take off the green
Put it
screen
up,
effect.
and then we'll put it back.
Okay, there's the real
That's where we
screen.
are.
But this is what it's looking like when Sam magic, right? So let's get started. First, I want to talk to you a little about science, and then we're going to do some fun experiments. Science is the study of knowledge. That's what the word science means. And it comes from the Latin scientia, which is knowledge. And so science is the study of knowledge. And just as a tree has lots of branches, science has lots of branches too. One branch could be biology, the study of living things. And even that has different branches. There's medicine, there's immunology. That's a big word that means the study of things that help you fight disease. There's all sorts of x-rays and this sort of thing that help doctors figure out what's wrong or take pictures of your body. That's all part of the subject of biology. Plants, how plants grow, diet, that's all a branch of biology, the best diet to have. There's also physics. Physics is the science of pushing and pulling. That's physics. And so when you're thinking about hitting a ball or how much fuel do you need to shoot off a rocket ship, that's physics. And then there's electricity. And there's lots of different branches of chemistry, how materials come together and change and form new materials. That's all part of science. So I think that's really interesting. You know, I've always thought there are three kinds of people, Sam.
Uh-oh.
There are people that make things happen. There are people that watch things happen. And there are people that don't know what's happening. So I'd like you to be part of the group that make things happen. And the way to do that is to help you and encourage you to understand more about the world we live in, which is the study of science. Now, here's some interesting facts. 140 years ago, homes had no electricity. No electricity. They would keep things, they would have lanterns that ran on oil, but there's no electricity. That means there's no TV, there's no radio, there's no smartphones, there's no, if it gets dark, it's time to go to bed. That's pretty much what happened. 100 years ago, radios were big, clunky machines that you needed to plug into the wall in order to get to work. 100 years ago. And 100 years ago, cars were first coming out, and you could get a car as long as the color was black. Cars only came in black 100 years ago. 70 years ago, air conditioning became available. 70 years ago. And about 10 years ago, smartphones became available. So how did all of these inventions happen? What caused these inventions to happen? That's what we're going to look at today. Sam, could you bring up the photo of scientific method, please?
Certainly, Marty.
Okay, so a method is a way of doing something. So a scientific method is a way of doing something to learn about how the physical universe, how the world works. And so the first part of scientific method is to ask a question. It could be a question like, I have some questions here. It could be a question like, how can you stop apples from turning brown? Or it could be a question like, how far does a sneeze travel? Or what's a good way to kill germs? That's a really important thing now. Or which protects against sunburn the best? That would be helpful when you're going to the beach. You don't want to come back and feel all sunburny and achy. Or what's the best diet for me to lose weight? Or what's the best exercise to make my arms stronger? This can be figured out by this scientific method, the scientific way of discovering things. And all of these questions were answered in the past that we just spoke about. Cars being invented and air conditioning, all that came about through this way of doing things, scientific method. You could also solve a problem like, why is my bike tire flat? Or why doesn't the doorbell work? That can all be answered with scientific method. So the first thing you have to do is think of a question or a problem that you want to solve. That's the first thing. And then do research. You know, you are so lucky, we are so lucky, because years ago, if you wanted to learn about something, you go to the library and see if you could get a book. That's what I had to do when I was a kid. I had to go to the library and get, if I was writing a report about something, and hope the library had a book. We didn't have the internet when I was your age. But now you can research easily. You could find out what other people have found out. So you don't have to do their work all over again. You can build on their work and get more and more knowledge that way. Then you make a guess. A fancy way of saying a guess is a hypothesis. So you make a hypothesis or guess as to why your bicycle has a flat tire, or what's the best way to lose weight, or whatever it is. And then you do experiments. If you're doing one on suntan, which is the best kind of lotion to block sunburn, you could have your arm or part of your body and put one sunburn lotion here and another one here and another one here and another one here, and then go to the beach and see which one gets burnt the least. That would be doing an experiment. And then you come back and you have to analyze the data. Analyze, that means find out what happened. So you can look and you see your spots here and you say, oh, this is really red and that hurts. And this is a little, this is hardly red at all and it doesn't hurt. And that's the way you can find the results or the answers to the experiment you just did. And finally, you make a conclusion You come up with that answer. This is the best lotion to put on my body so I don't get sunburned. That's what scientists do. That's how scientists have made all of these advancements, from electricity in the home to radios and TVs and cell phones and air conditioners. I think it was about 60 years ago, color TV started coming around. Before that, if you wanted to watch TV, it's in black and white only. I'm going to tell you a quick story. Sam doesn't even know this. When I was growing up, we had a TV downstairs, but my dad got this TV for the kids' room. The TV was this big. I don't know if you can see my hand all the way. Was this big and this high and about this deep, and the screen was like this big. And now, of course, look at all the advancements that have been made. I remember when I got my first job, we had a room full of computers. Now, my cell phone has more information and more data than that whole big room 50 years ago. So technology, the way of doing things, the way of learning about things is advancing. And the way it's advancing is with this scientific method, the scientific way of finding out about how the world works.
Nice. Do you want to run through an example of that, or you want to move on from there?
I want to
take. Okay.
I'd like to talk about, unless we have some questions.
We don't have any questions yet, other than people amazed by our green screen.
Woohoo!
And amazed by what old TV might be like. Where'd Marty go?
Okay,
awesome.
So
I do want to add one thing.
Go ahead.
One of the things I love that you talked about in the scientific method is starting with the simple idea of noticing you don't know something.
Right.
You can't know anything until you actually decide or notice you don't know.
Yeah.
Right.
And some of the greatest inventions and discoveries started with someone saying, I wonder why that happened. And then they did research, they did experiments, and they found out. And that's how we got radio and TV and all of the modern conveniences, the air conditioning in the car that I didn't have when I was a kid.
Yeah, somebody had to at some point say, there's something to know that I don't know.
Or there's a better way of doing something.
Mm-hmm.
And so they investigated, they did some testing, some experimenting to find out what was best. So let's bring up.
Good, we had a couple questions.
We have a couple
that
questions.
did come in that we should move on now. So
Okay.
One is, what is chemistry and what is physics?
Okay, so physics is the science of motion and forces. So if you want to know, how much energy you're using to pedal a bike, or pedal a bike when you're going up a hill, or how much energy, how much force is needed to push a heavy table or a light table. Well, of course, that's easy stuff. But what if I'm talking about launching a rocket ship? How much fuel do I need? Well, I'd like the rocket ship to escape the Earth's atmosphere, but I don't want it to go beyond Mars. I have to have just a certain amount of fuel. And how much weight is needed? The more fuel, the more weight. So all of this figuring is the science of motion and forces, which is physics. Chemistry was the other one?
Chemistry was the other word.
Chemistry is the science or the study of how different things combine and change. So for instance, if you got, let's see, if you have something we did a week ago or 2 weeks ago when we had baking soda and vinegar, you remember that? We had a big container and we put baking soda and vinegar in there. And then we had candles over here on the table and we poured out the gas, and the gas put out the candles, put out the flame because of chemistry. Vinegar combined with baking soda to form this gas called carbon dioxide. That's the same stuff that you and I are breathing out right now. We're breathing in oxygen because our bodies need oxygen for energy, and we're breathing out more carbon dioxide. And so all people do this and all animals do this. Plants do the opposite. They breathe in carbon dioxide and water and take in sunlight, and they make food. So when you're eating corn or rice or any beans or anything like that, that's the energy from carbon dioxide and water and sunlight. So anyway, that's what physics is, the science of motion and forces, and that's what chemistry is, the science of how things combine and change.
Perfect. And then somebody wanted to know who invented the scientific method.
I don't know. That's a great question. I have no clue. But somebody must have sat down one day and said, you know, how is it that we can learn these things? And they just wrote down the different ways. Now, there are different scientific methods. Some of them vary a little bit. So sometimes it could be just asking a question and figuring out an experiment. That would be a theoretical scientist, someone who thinks about an idea. Theory is like an idea. Einstein never did an experiment in his life. Einstein is a very famous scientist. He never did an experiment, but he was a theoretical scientist. He thought of these ideas and said, well, I bet if you did this and this and this, that would work. And then other scientists will carry out another part of the scientific method and do the experiment. And they'll come up with the idea of, boy, that Einstein knew his onions. He was really good at something and he had a good idea and his ideas work. So let's bring up a picture of the atom.
Picture of the atom.
There it is. So you might have seen this before. This is, of course, a drawing of the atom because atoms are very tiny. Here's a shocking statement. Scientists have never seen the parts of the atom. Atoms are made of protons, neutrons, and electrons, and scientists have never seen any of those parts. Well, you might ask, how do they know they're part of the atom? Well, they've done lots and lots and lots of experiments and used scientific method. Scientific method, don't forget, is a science, a way to figure stuff out in science. So they've done lots of experiments and said, that's interesting. I wonder if this would work. And then they try an experiment and then they did that. And they've done that for a long time. And they find out more and more and more about the parts of the atom until they come up with this drawing or idea of how they think it looks.
Perfect. All right, 2 more questions.
2 more.
Where are we? People want to know. We're in the science lab. We're actually not in the science lab, but the background for us is what the science lab in our school looks like. And
My science lab.
His science lab that I sometimes come and borrow. And then the science lab is actually just across the hall. We're pretty close to it. We're in a small seminar space where we do some seminars. And then Lorna said something that I think is really important to notice. She said, wow, I knew something you guys didn't. That is really shocking. And I just want you to know, Lorna, we don't think that's shocking at all.
No.
We're not saying anything about us. We know a lot of things, but we learn so much from students all the time. We think that's a really important thing for you to think with as a student and for teachers to think with is students should have answers teachers don't have all the time. They should be asking questions that lead to things teachers don't know. So keep looking and don't ever think the teachers know everything.
Your job as a student is not to be a sponge and absorb whatever the teacher says. I think your job is to find out about things and be curious about how the world works and learn and find something that interests you. You know, my grandfather used to say, it's a rich man or woman who gets paid for doing their hobby. If you find a job or a subject that you love doing, I don't care if it's driving a bus or finding out about atoms or whatever. If it's a job that you enjoy doing, that's the key to having a happy life. So Now we're going to jump right to some experiments, unless Sam has something else for me to.
No. People
Oh.
want some experiments. and
Experiments.
so do I. Marty says we're gonna burn some things today. That's how he got me to come.
Yeah, yeah. So here I have a jar of water. Ooh, and I don't know if you can't see this probably, but there are little tiny drops of air, bubbles of air in the water. That's something else we could do at another time. But so there's air dissolved in the water, and when the water gets a little warmer, the bubbles come out. Did you know fish breathe air that's in the water? They don't have to come up to the top and take a deep breath. Whales do, and dolphins do, but that's another story. Anyway, so there's air dissolved in the water. So now I'm going to take this cardboard and I'm going to put it upside down here. Now that air, that water's pretty
Marty,
heavy.
Sorry, everybody. I have the atom picture up. This should be much better. You might want to start from the top if you can, because I don't think they could see very much of that.
Water, cardboard, top, upside down. Now that water is a lot heavier than the air, isn't it? So when I move my hand out of the way, it should fall down. So I have this container here just in case it gets really wet. But look at that. Why does it do that? So this could be something that you could apply the scientific method or the scientific way of figuring things out. Why is it that the air, Sam, what are you doing? That the air,
I'm checking.
That the air,
curiously,
that the water stays in. Well, I'm going to show you something else. I'm going to take this and I'm going to pour this water in here. And I haven't tried this, so we'll see if this works or not. So I'm going to take this and put it upside down, and I'm going to move this away.
Whoa.
And
I did not expect that.
You didn't expect that. And look, I could take this toothpick.
Let's put this under, because we need to show people what that is.
Oops. Can I? No, I can't. But
wow. That
why is that
unbelievable.
doing that?
First of all, I don't know if everybody can see, so let's show real fast. So this is what was on the bottom of that. It's full of holes.
It's full of holes.
It's just a screen of holes.
Right.
But it held the water in.
It held the water in. So why does it do that?
So we have some thoughts.
Yes?
Isis says maybe it's suction.
What is suction? It could be suction, but what is suction? Okay.
Do we want to answer? Or?
I don't know. I was hoping to get some answers from you guys.
Well, we have a whole bunch of other potential thoughts. So let's go through some of them.
Let's go through some of them.
All right. Isis says maybe suction. Katie says because the water makes it stick.
The water makes it stick.
Adya says push it down.
And we did.
Sorry, Hadia. I don't know if that's how you say her name. Sorry if I'm messing it up. But Hadia says it's air pressure.
Air pressure. Right.
Lila says because the air isn't rushing out. That's
right.
True. Olivia says because there's air in the cup. Ethan says he knows why. Let's see what he says. He says there's air pressure all around us, making the pressure the water is giving more than the air pressure.
Right. So if I take this and I put it back here, and if I put this upside down, there's air pushing down, and there's also air pushing up here, this way. And the force, remember, physics is the science of motion and forces. There's more force from the air pushing up than there is from the weight pushing down. Wow. And that's why it stays, if I don't, that's why it stays up like that. We missed the computer. Okay, that's the important thing.
Well, that's pretty cool.
Okay.
I can't believe that it didn't come through the the screen. That can't be just because of the pressure.
Oh, no,
that must be a whole different
that's something else. That's something called surface tension. So we could do a little experiment with surface tension. I wasn't planning on doing it, but I think we have this stuff somewhere here. Well, let's see if we can get to it later.
Surface tension's the answer, though. And that's a cool thing. We could at least stop there and say, if you want to know more about surface tension, Google it.
Right.
Check it out. See what you can find out. And then you could do some of your experiments on your own, make some predictions, and see what happens.
So I'm going to put a little water in this balloon.
Oh, good. Not the green one. This balloon, I think, Marty, is causing you to disappear. It's greenish. So I'm going to put that over here until you're ready for it.
Let's see if I could put the top on that so it doesn't spill. Now, I'm going to get out my handy dandy lighter. I'll light that one first.
Okay.
Then I'll light this one.
Okay.
Now,
Do you want me to zoom in on those, or are we okay?
sure, you could zoom in.
I think we can see, but they're a little small. You know? This works. Oh,
Can you
that
get it
does
okay?
work. Okay, here we go.
Okay, so come on over here, Sam.
Okay, we just have those. Do we need room above them?
A little bit, maybe up to here.
Okay. Okay.
Now, first thing is I'd like, Sam, I lit too many. Could you blow this out, please?
Bring it down.
Yeah, thank you very much, Sam. What? Oh, sure, you blew it the wrong one. So why is this is one of those fake birthday candles that you blow out and then it relights. Do you see those sparks? We'll see. Let's see if we can see those sparks. Come on, spark. We'll see these sparks will look like something else we'll be doing in just a few minutes. So right now, oh, there we go. There's some sparks. Ooh, except there you go. You see them?
Good.
Okay. Whoa! So now in order to, I just have to put water on it to get any heat out. That's the way to stop that. So now we have our one. Now let me have that green balloon that nobody can see. You can sort of see, oh, isn't that interesting? Isn't that interesting?
Do you want me to pull off the green
No,
screen
no,
effect?
no, I love it. Look at that. That is cool. Anyway, I'm holding a green balloon. Let's see, can you see my, no, you can't. Look at that, it goes right through me, through my, why, yeah, okay, anyway. So if I take this balloon that you can't see here, and I think that's cool, Sam, and if I put it over the flame, what's gonna happen? Of course, it's going to pop. Here's our first explosion, Sam. Whoa!
Oh, look at that.
So it popped. Now,
I was just, never mind. Carry on. I was being curious.
so here is a balloon,
I can't
and
see it. Do you want me to zoom out?
you can't, oh no, here it is.
Here you go. Here, I'll get that one.
And what I'll do now, I'm gonna move this here.
Okay.
I'm gonna move it there. So now I'm gonna put this, remember this has water in it. I'm gonna take this and I'm gonna put this right over the balloon. Yeah, you might wanna zoom in a little bit. And have it there, and have it lower. Okay, good. So I'm gonna put this over and let's see what happens. You see it's right over that flame. And look, look. So here's the balloon, and it's right, as a matter of fact, they could push it so far down that it, so we know that balloons are made of this really thin material, and we know, look at that, And we know that fire, we just saw the fire pop this other balloon. So what happened here? We just did an experiment and we came up with a result. And I'd like you to figure out, why do you suppose that is? I'm going to try it again. I'm going to hold it up here so you can see it. And hopefully this doesn't break. Look at that. The balloon didn't break.
Wow.
What do you suppose that is?
All right, let's see what we have coming in.
Let's see what we have coming in.
Many people predicted it will pop or it won't pop.
Ah.
Some people said it was an X-ray balloon. True. All right, but we have a few answers to that. So Annabelle asked, does it have to do with the pigment, meaning the color? That's
Not at all.
Thought.
Nope, pigment doesn't have anything to do with it.
April said it's because of the water.
The water, well, that was the difference, wasn't it? I mean, besides the difference in color of the balloons, there was the water. The balloon that didn't break, this guy, had water in it. So how could that possibly prevent the balloon, this little thin balloon, from breaking?
Yeah, Hartley says the water was protecting the balloon, which I think is a step forward, but we still have the question.
But the water's on the inside. The water's on the inside. It's not on the outside protecting it.
Katie says maybe the water cooled the candle down, so then it just made it black.
Well, that's a good guess.
Shanna said it cooled the flame down.
Hmm.
Now, this is an interesting thought. This is thinking outside the box. Lorna said maybe the balloons are different. Maybe they're different brands.
No, same balloon, same package, different color.
Okay.
But a good thought.
Annabelle said maybe one of the balloons is more blown up than the others.
No, they're both blown up about the same.
A lot of people say the water is cooling the balloon.
Right. The water on the inside. So what happens is when there's a flame here, it goes through, the heat goes through the balloon. And if there's nothing but air inside, one part of the balloon will get very, very hot and tear, and the balloon will pop. But because there's water, the water absorbs the heat. The water absorbs the heat. Now, you've probably noticed if you go to the beach in the summer, sometimes, or if you're just outside when it's hot in the summer, if you're in water, it's cooler. If you go into your mom or dad's car and your leg hits the seatbelt buckle, how does that feel? I've done that before. That's really hot because heat, a little bit of heat will raise the temperature of metal, like your seatbelt buckle, and a little bit of heat will raise the temperature of water a teeny tiny bit. Water is a great absorber of heat. So that's why the balloon didn't pop. And that's why in the summertime, keep your bare legs away from the metal seatbelt buckle because it's really, really hot.
Perfect.
Okay. Now here's something I did yesterday. I took some water and I put it in this container. And then I added sugar and I shook it up, and I added sugar and I shook it up, and I kept adding sugar. And what happened at the bottom? Can you see that? Yeah. What is that at the bottom? That's sugar that didn't dissolve. So even though I took it and I shook it up, as much of the stuff, you might see it swirling around there. You can see the little pieces perhaps. In any case, the sugar, some of the sugar didn't dissolve. So what you can do is we're going to talk briefly about these three words. Saturated. Saturated means it's holding as much of the stuff that can dissolve as it can hold. So this water is a saturated sugar solution. It's holding as much water as it could hold. Now, if I took this and I dumped this into a pool of water, a great big swimming pool, it would still be a sugar solution, but it would be unsaturated or not saturated, not holding as much as it could possibly hold. I could still dump a bunch of sugar into the pool and it would dissolve. So far we have saturated, holding as much as it can, and unsaturated, not holding as much as it can. Now, there's another word that has saturated in it, and that's super saturated with it. Now, super means above or beyond or more than. So here, you're probably familiar with this. You might have done something like this. Here, I took some water and I put a whole bunch of sugar in it, and then I had a whole bunch more, way more than this, and then I heated it up. And when I heated it up, all of the sugar dissolved. And then I slowly cooled it down, and I put this little coffee stirrer in there. And then I added a little bit of blue food coloring so you could see it better. I'm glad it wasn't green food coloring. Sam.
Yeah, that would have been a problem.
And then when I take it out, here's the excess sugar that's on this coffee stirrer. I have a couple more that I did the day before. They're not pretty, but they're really sweet and delicious. So this is something you could do at home. You could make these things at home. You could get some sugar and dissolve it in water. Doesn't have to be a lot of water. I just had a half a cup of water and about 2 cups of sugar. And I used a microwave, but you could use a pot on the stove. And I have this is super saturated. It's holding more sugar than it should. And so the extra sugar can come out onto the stick. Now,
good. A lot of people are asking, is that crystallization?
That is crystallization. Crystallization means becoming a crystal. And a crystal is just something that's solid with a repeating pattern, like a snowflake. A snowflake is a crystal. It has a repeating pattern. Or a diamond, or a jewelry, rubies and sapphires and that sort of thing. Those are crystals. They're made up of very, very, very tiny atoms, and they're built in a regular repeating pattern. Now, I have something else here that is super saturated. I have a red plate here. You can all see the red plate. And here, this looks like sugar. This is this powder called sodium acetate. And it just so happens I have here some sodium acetate that I heated up and then cooled down. So I put lots and lots and lots of sodium acetate in there, and then I cooled it down. So Sam, I want you to be my assistant here. If you'll take a little piece of sodium acetate.
How little?
Any size. That's,
yeah, let me hold it and see if I can. Good
okay,
enough?
good enough. And I'm gonna lift this up, and what I want you to do is pop it in there. So Sam is popping it in there.
Let me see if this can be seen.
And look at can you see what's happening?
Whoa.
So now all of that
unbelievable.
extra sodium acetate is coming out, just like the sugar came out on the coffee stirrer because it was too much. And hold the bottom, Sam. It's nice and warm.
Wow.
This is the stuff that's in hand warmers.
Interesting.
So it just so happens.
Oh, look at that. It's the whole thing is
The whole thing is solid. Yeah, see this?
Oh,
Nothing's coming out.
that is fascinating.
Yeah. So this is sodium acetate. Now what I could do, I could take this and put it in the microwave and stir it up again and dissolve it and reuse it just the way you can use hand warmers. Now, if I take a little of this sodium acetate and I put it on here, can you see it on the, maybe we could zoom in for this, Sam.
All right, Becca
Zoom in
is
on the,
in here, and she is much better at the camera than me anyway, so we'll let her do that.
so here is some
That's pretty good.
Here is some more of this sodium acetate that is super saturated. Remember, it's like if you go to one of these all-you-could-eat places and you eat too much, and if it's a curvy, bumpy ride home, you feel like throwing up, right? Well, that's what this is. This is holding way too much of that sodium acetate chemical. So if I just start to, now the reason I have this top on is because, as you could see, even a little crystal, a little bit that would get in there would make all of that excess stuff come out. So watch, I'm going to take this and I'm going to see if I can get it going here and see. Can you see this little mountain forming?
Oh my goodness.
So as soon as this supersaturated solution, as soon as this stuff hits the solid, all of that extra stuff is coming out. This would be a great science experiment if you need to do a science experiment one year. Look, I'm making a little tower just by pouring it.
Just for comparison, look how high that's getting. There's my hand next to it.
Now, when you're doing this, be careful not to touch not to touch that with the liquid in here, because it'll turn this solid.
Interesting.
But
I think we should try that. Do we have anything to get it? No.
sure.
Oh,
Well, here, I can just do this. I'll just pour it in.
Oh, wow. Look at that. That's
And
awesome.
If I do this,
Lorna says, what in the world?
is that cool or what? Now look at that. Can you see that? Can you see it changing in this container?
Yeah, kind of. It's a little hard to tell, but this line right here, that's growing this way, that's the solid that's growing into that liquid.
Yeah, so now I'm taking it.
Wow.
And I'm turning it upside down, and it's all solid in there. That's solid sodium acetate. So if you're looking for a fun and interesting science experiment, we could do it one more time because I have one more container. Do we want to do it one more time?
Well, Marty, let's check in because I don't know what else.
How much time do we have?
We have 1 minute and 30 seconds left. Do you want to do that one more, or do you want to try to get one more other experiment?
Oh, there are so many interesting experiments that I have. Is it okay if we go over a little, Sam?
Yeah.
Okay,
I
good.
mean, we always do. So
To burn things. I mean, we're going to burn things.
we, you know, if we get in too much trouble, somebody will come in and tell us to be done.
So this is a little alcohol burner that I have. And once I get it started, I don't know if you can see that flame. It's a very light flame. And now I'm going to take a little bit of water.
Let's see if we can see the flame. Let me pull this up. Well, because we're on the green paper, everything's a little bit funny. I'm going to turn the green screen off.
Okay.
And it might help. Let's see.
I'm going to take the paper out. I'll put it on here. Can we see that better now? Well, it's hard to
Not
see, but
really.
you don't have to see that because this is what I wanted to show you. Would that be
That's
better?
a good idea. Let's try this. Here, can you move the... Let's see if that background gives it any more... Nope.
Okay, we'll just put
And
this.
here's what we can do for proof. Is if I put this...
Well, that's in water, Sam.
well, if I put this, and you can see there's a fire there. So
Or
if
if
you
I
can't
take-
see it there, there's a pretty good fire coming off.
If I
these.
take this chemical and I put it in here, whoa,
Yes.
can you see that color? This is also something you could do for your science fair experiment if you need to. These are just different colors, different chemicals that I have. And I'm putting them in different containers. Here's one. This is, would you put the lid on that, Sam? Put a lid on it.
Sure, Marty.
This is table salt. This is the stuff you put on your French fries. So if I take this, now the other one was sort of a green. Let's see what kind of color this is going to be. This is a more of a yellow. I don't know if you can see that. What if I hold it like that? Was that better? I think that's better.
So I'm guessing this is some of the science behind the 4th of July type fireworks that we have.
That's right. Oh, wait till you see my next, the last two that I do.
Can't wait.
This is strontium. This is the chemical that has the element strontium in it. And it's one of my favorite because when I put that in there, can you see that?
Wow, that's beautiful.
Can you see that color? That's like a red. So some of these have different colors. We saw a green and a yellow and a red. Now, here's my two favorite. Sam, I did this for you because I knew you were going to be here today, and I know you love burning things.
No, Marty. Oh, yes, yes, it is true.
So this is just a little iron powder, but
wow, that's like sparklers, huh?
Yeah, it's like sparklers. And they use this sort of thing for fireworks as well. Wouldn't this be a fun science experiment to do for a science fair?
Absolutely.
And look at it. This is what they use. Is it the 4th of July already?
Must be.
Whoa!
There's sparklers in the air.
And there's one more. We just have one more. Whoops. I hope we don't catch fire. Okay, here we go.
Hope we don't set the smoke alarm.
This is a metal called magnesium. And it's a powder, and it's what's used in sparklers because when it burns, it's really, can you get a zoom in here? Whoa!
Fabulous.
So you might have seen little sparks like this earlier in our demonstration. Remember that candle that I was tricking Sam with that wouldn't go out? That had little bits of magnesium in it. And I'm just going to put this on. This is how you shut this off, plunk. So there was magnesium inside the candle. So the candle would still stay hot and would still relight because it had little bits of magnesium. You might have seen those little sparkles in there.
Marty, since we're basically out of time, Lorna had a really good experiment idea.
Go ahead.
We have the green screen. We can create green flame. I think it'd be fun to see what happens if we create green flame with the green screen on.
I'm always game to burn things, Sam. You know me.
All right, let's do this before they come in and shut us down because we're going so long.
We're going so long, but we're having fun, aren't we?
Do we ever not have fun?
No.
All right, hang on. Let me get a green screen up.
Okay, let me get the chemical. Here's the chemical that, let me put that in the middle here so you can see it. How's that? Okay, and now I'm going to get this piece. And where's the guy that turned green? Here's Strontium back.
Okay.
Okay, so this is copper. This is a chemical that has copper in it. Copper is the stuff that pennies are made out of, but these aren't ground up pennies. This is two different kinds of chemicals that combine. So when I have that in here, can you see that?
Yeah, we can.
Oh, move my arm.
Your blue
Okay.
sleeve is.
Wow, there's little holes of disappearing. That's pretty cool.
Okay,
Well,
oh,
that
there's
was a
some
great
blue
idea.
too.
Jeez, that was beautiful.
Okay, well, thanks for joining us again today. Let me just close this down so we don't burn ourselves.
Good idea.
Thanks for joining us again today. I hope you had fun and learned something, and I hope I've inspired you to stay curious because curiosity is what will defeat boredom. If you're feeling bored, start feeling curious about something and your boredom will go away. So keep interested in how the physical universe operates. That's what science is. And until next time, have a great day.
Good. A lot of people are asking, how do they do these experiments? A lot of them are in the everyday chemistry course.
A lot of them are on our everyday chemistry course, right?
So we didn't have time to tell you how to do them, but if you go to the Heron Books website, a lot of them can be found in there. And you can find a lot of them just by Googling too. Like the rock candy, you can do it on the everyday chemistry course, but
Right.
you can Google it as well.
Right.
So good luck to you. Hope you can find them. We're going to put this Heron Books discount code up for you. So if you want to go get that course, you have a way to get it cheaper.
And we'll have some other experiments next Friday. We're going to do some other fun, learn about some fun things on Monday and Tuesday. But next Friday, we're going to do some more fun experiments. I hope you can join us then. Until then, have a great day.
Goodbye, everybody.
Bye for now.